Hello and welcome back. Okay, today I'm going to be continuing the process of converting the ALU into PCBs. So what I want to do is the LHS input. So that's these 8 wires here, or here, and currently that's handled by this breadboard. The LHS input goes to the shift unit, and its input is from the left-hand side bus. Now it's got 2 control inputs in addition to the ALU clock, and that just selects 4 possible outputs. First one is the undoctored value getting passed through to the next stage in the ALU. You've got the value being passed and shifted down by 1 bit, or the value input being shifted up by 1 bit. And the final mode is just outputting a 0, which is used when it's predominantly the RHS side which is doing anything. Right, now I've got the Fibonacci sequence program in here. So we've got the normal output. The 23rd value is 46,368, so that shows us it's working. Now you might think that the Fibonacci sequence doesn't really involve the shift unit, but it's actually a pretty good, robust test of all the mathematical capabilities of the ALU, because it's doing lots of division operations to create the decimalised form of the numbers, rather than the binary form that's actually inside the processor. Let's go and look at the design of this thing. Right, so when we made the back plane, we stubbed out what the LHS shift unit was going to be. So here are the main inputs and outputs, and this is the space that we reserve for it in the back plane. So hopefully we can fit it all in here. If not, I'm going to feel silly. Now the main working of the shift unit is 5 4-to-1 selectors. So this is an output enable line. The 153 is not the tri-state version. I think it just outputs all zeros when you don't enable it. Now these outputs are the outputs on the breadboard version, and they're definitely the inputs into our LEDs for displaying the status. But I'm thinking of using the 574 latch chip here to bring the latch functionality from the control down, as I think it will be slightly neater. But we do have the option of not doing that if we run out of space. Right, so this is output line 0 and output line 1. So this is basically just 2 bits being handled on this chip. Now we just need to go and reference what these control lines do. So 0 input means unchanged. So we output 0 and 1. Input 1 is shift left. Now, of course, the moment I put this chip down, I realised I have missed something from the inputs, since the 5th chip is controlling carry generation. So control 0 is still unchanged for all of them. And in this case, the bit that we pass as carry out is just carry in. Right, so number 1 is shift left. So bit 1 becomes carry in, or bit 0 becomes carry in. And that pattern repeats all the way down. And then this 8th bit, which is shifting off the top, is going to become the carry. Input 2 to all of these is shift right. It's going to be easiest to do all of these in reverse order. And of course bit 0 is being shifted off the end, and that becomes the carry. And in this fourth mode we're outputting 0. Now I've just noticed a difference between the breadboard circuit and my original design. In the breadboard circuit, this line is tied to ground. So that means the logical carry doesn't get preserved. I've got a choice here of building the circuit with my original plan, but I should fix the breadboard and give it a test. What I've done here is given myself a jumper to specify one behaviour or the other. Bit of a hack, but that lets me move on to the PCB completion now. Right, so the latch gets driven by ALU clock. And that always outputs. And what we do lack is wires for logical carry in or logical carry out. Easily fixed. We will need to place that on the PCB. Does look moderately tight. I think we're going to be able to fit it okay. Now on this one, carry in is just logical carry from flags 4. Really need that ground. Back in the right place. That's definitely the wrong way around. That was nearly a terrible mistake. Glad I caught that. The LEDs I've used here are the ones that don't have anything on the PCB to show which way round they go. It's a recipe for disaster. Right, so these are just going to be showing the input values. It's going to make so much more sense if I stack these vertically here. Probably going to be cheeky and put these on the back. Now all I have to do is route them in. Because the wiring here is far denser than anything I managed on the earlier PCBs. I do wonder how much smaller I could have got some of the early register boards if I routed them now than when I was a complete novice. It's definitely getting quite tight here. Right, it still feels achievable, but it's getting messy. If I ever really struggled with one of these boards, I could always switch it to 4-layer, so all these power and ground lines just go away. Okay, that felt untidy, but it will work. think I'm better off going the other way for this. When I arranged the size of LHS and RHS, the shift unit and the logic unit, I was thinking predominantly about the number of selector chips. And I think I'd have been better off with slightly more space for this one. It's really close to being done though. Okay, that felt like an epic routing effort. Alright, see if that will hide it under the chip. Right, so this line I've not used. I'm going to want a copper area. Now I've got that rear line, maybe I can get the copper area in. Okay, it's only $1 difference between 5 and 10. Okay, let's take a look at this. Always exciting to get a new PCB. That looks pretty good. I want to do the capacitors first this time. Okay, control lines are 2 8s and 2 4s. Do need a 0 ohm jumper on the back here. Now I've got These jumpers give me the choice between how I implemented it on the breadboard and how I originally designed it. And this is just the behaviour of the carry flag with instructions that don't affect the logical carry. While waiting for this PCB to arrive, I did have a think about the situations in which it would make a difference, and it's pretty rare. Next time I do an order, I'll have to get some 0 ohm resistors because that's basically what they're designed for. Okay, now that felt like a very easy PCB. This chap looks very slightly skewed. Looks like the contacts are still in the right place though. I think the best thing to do would be to give it a test. Okay, this obviously goes in here. That looks nice. Now what we don't have is the crucial inputs and outputs necessary to drive it. So it should have the LHS input. We've got carry in, carry out, and the 2 control lines, and we've got to get the output back to here. But initially I'm going to see if I can hook it up and make it operate in parallel to this one. Right, we need the control lines to come straight across. The top 2 should not be necessary. So these should only last as long as it's necessary to not have the... These will get replaced when I put the new control in. Now we're going to need the ALU clock. So the ALU clock is there. Right, so there's the carry in. Oh, that shouldn't be necessary because we've already got the carry line on the pipeline. So that's coming across from this wire bundle. We are interested in carry out though. That's there. And that will need to replace this line. Comes across and goes down to the LHS unit once we get that far. And now it should be doing the same thing as the existing unit does. Right, so we're not testing it right now, we're just getting it to shadow. It's just passing through at the moment. Okay, I think that's a shift right. Now I need to work out how to force it back in here. Right, so we should be getting the result out right there. And at the moment the result comes over to this latch chip here, but we've duplicated that functionality on this board, so we actually need to remove this latch chip. Right, so that's the carry out from the shift unit. And that has produced the correct result. Oh, that's awesome. Back to work first times. Let's not talk about this one. Okay, so this is all a little bit messy. It would have been better if I'd preempted that I'd need to make these connections and put an extra little header on the side here. We can get rid of one of these cables when we move the RHS section over. I can't really extract this breadboard very easily, but once I've done the RHS section, which is the lower 2 breadboards, it should all come over. That'd be cool. ALU control is mostly the diode matrix, and we're using some gates from these 2 chips. But I think this is an awesome place to be in now. First bit of the ALU is now PCB, and that just looks neat, and it gives us an idea of what the rest of this is going to look like when it's done. I'll be able to move my temporary display down here, or at least have this whole area to work on without pulling the camera to it. out too far. So that'll be cool. Hope you found this interesting. I'll be back with an RHS logic unit video fairly soon, I hope. So I will see you again soon. Thanks a lot. Goodbye.